Welcome to day 28, Disease Prediction using ML Algorithms. Now in this project, the objective is to build a machine learning model to predict the likelihood of heart disease based on patient health data. The model will leverage supervised learning algorithms to analyze key health indicators and classify whether a patient is at risk of heart disease. The steps that we will follow is: first we will load and explore the dataset. Next we will pre-process the data. We'll split the data into training and testing sets. We'll train the ML models. We'll evaluate the model performance and make predictions on new data. And finally, we'll visualize the results. So for the data sets, I have used Kaggle's heart disease dataset. I've already downloaded in my project, and this is how it looks like. These are the different fields we have: age, sex, this is the chest pain, we have blood pressure, we have cholesterol levels, we have blood sugar, we have resting ECG, max heart rate, exercise induced enigma, we have ST depression, and our target at the end is at risk of heart disease for 1, and 0 is no heart disease. So let's go ahead into our project and let's implement this application. So as usual, our step 1 will be to import the required libraries. I'm going to import pandas as PD. This is the library for data manipulation and analysis. Next, I'm going to import NumPy, which is a library for numerical computations. Then I'll get the train test split and grid CV from sklearn.model_selection. Train test split splits the dataset into training and testing sets. Next, we have the standard scalar, which is from sklearn.preprocessing. It standardizes features with mean equal to 0 and standard deviation equal to 1. Next, I have the logistic regression from sklearn.linearmodel. Now here, this is the classification algorithm used for binary classification. And since we have yes heart disease, no heart disease, that's why I'm using this. Next, let's import random forest classifier from sklearn.ensemble. This is an ensemble method for classification. Next, I'm getting the accuracy score, confusion matrix, and classification report from sklearn.metrics. Now, accuracy score measures the model's accuracy. Confusion matrix displays true, false, positives, and negatives. And classification report is for detailed performance report of a model. Next, I'm going to import matplotlib.pyplot as PLT, which is used for plotting graphs, and import seaborn as SNS, which enhances visualization with statistical plots. Next, I'm going to also import warnings. This is just so that we don't see the warnings that are unnecessary for this project. So I'm going to import that, and I'm going to say warnings.filter warnings and ignore the warnings for now. If you want to see the warnings, you can remove this part from here. Next step is to load the data set. So this is actually the first step, which is loading the data set. So I'm going to say df equal to pd.readcsv heartdisease.csv. I already have that file in my folder, and that's what I'm importing. Now this pd.readcsv loads the CSV file into the data frame from that particular location, which is in my same folder. If you have a URL or if you're using some other file, make sure that you change that to that particular URL or file. Now the dataset purpose here is the heart disease dataset for predicting heart disease presence, and that's what you saw in here. Next step is to display the first few rows. So I'm going to say print dataset sample, and I'm going to say print df.head. Now the df.head, as you know, displays the first 5 rows of the dataset. Next, I'm going to do data pre-processing. In here, I'm going to handle the missing values if there's any. So I'm going to say print missing values df.isNull.sum. I'm going to check it out if there is anything. df.isNull identifies missing or null values, and .sum counts the null values in each column. Next, I'm going to do some feature scaling. Here, I'm going to say scalar equal to standard scalar. This initializes a scalar. Then I'm going to say scaled features equal to scalar.fit transform df.drop target axis equal to 1. So the fit transform fits the scalar and scales numerical features, whereas df.drop target and axis equal to 1 drops the target column to keep only the feature column. So if you see here, I have the last column as target, which I want to drop and just keep the feature columns in this particular case. Next, I'm going to say x equal to pd.dataframe scaled features columns equal to df dot columns minus 1. Now this x stores scaled features as a data frame, and then I'm going to do y, which stores the target variable, which is the target column. So y is our target column. That's what we want to predict, and that's why we keep it in the y variable. Next, let's go step 3, split the data set. So I have x train, x test, y train, y test, train, test, split, x comma y, test size equal to 0.2, random state equal to 42, and stratify equal to y. Now the train test split, as I mentioned, splits data into training, which is 80%, and testing for 20% sets. That's where I specified test size equal to 0.2, which reserves the 20% of data for testing. Next, I have the random state equal to 42, which ensures there's reproducibility. So every time you run this, it will get the same set of data. Stratify equal to y maintains the same class proportion in train and test set. So make sure that there is no bias in there. Next, I'm going to go ahead and step 4, train multiple ML models. In this particular case, I'm going to start with logistic regression first. And here I'm going to say log model equal to logistic regression, which initializes a logistic regression model. Then I'm going to say log model dot fit x train and y train, which trains the model using the training data. Then I'm going to say log preds equal to log underscore model dot predict is the function that I'm calling, which predicts outcomes on the test data. So I provided the test data, which is x test. Next, I'm going to go ahead and get the accuracy of the logistic model. Log accuracy equal to accuracy score y test and log preds. This calculates accuracy, as I mentioned. And then finally, I'm going to print the logistic regression accuracy, log accuracy up to 2 decimal places. And log accuracy again stores logistic regression accuracy. Next, I'm going to go ahead and do the same thing for random forest classifier. I'm going to first say RF model equal to random forest classifier, n estimators equal to 100, and random state equal to 42. This initializes a random forest model with 100 decision trees. Next, I'm going to say rf model dot fit x train and y train. This trains the model using the training data. Then I'm going to go ahead rf underscore preds, where I'm saying rf underscore model predict x test. Again, this predicts outcome on test data. Again, for accuracy, I'm saying creating a variable rf underscore accuracy, and I'm calling the function accuracy score. Pass it the y test and rf preds this time. Then finally, since RF accuracy stores the random forest accuracy, I'm going to print that out and say random forest accuracy is RF accuracy. Again, just to compare, I'm going to say 0.2f as same as our logistic regression accuracy. Next, let's go ahead and evaluate the best model out of the two. So I'm going to say best model equal to RF model if RF accuracy is greater than logistic accuracy, else log model. Same thing, best predictions. Who has the best prediction? I'm going to say RF preds if RF accuracy is greater than log accuracy, else log preds. And then, so this is where we do the model selection. We choose the model with the higher accuracy. So I'm going to say print best model metrics. Accuracy score is this for accuracy score y test best preds. Classification report, we say classification report equal classification report of y test comma best preds, and confusion matrix of confusion matrix y test comma best prediction. So the classification report again will display precision, recall, F1 score, and support, whereas confusion matrix displays the confusion metric values, which are true negatives, true positives, false negatives, false positives. So let's go ahead and visualize the confusion matrix now. So for that, I'm going to create a plot.figure fixed size 86, which sets the plot size. Next, we have sns.heatmap confusion matrix equal in y test best preds is what going to pass there. Annotation equal to true, CMAP blues, that's the colors that I want, and format equal to D. So this will display the confusion matrix as a heat map. Then I have plot.title equal to confusion matrix, so this will create the title. Again, above we had annotation true, someone asked earlier. This annotates metrics with the values, and as I mentioned, this is CMAP is for the blue colors. Next, I'm going to say the Y label is actual, X label is predicted, and then I'm going to say plot.show. So this will show me my confusion matrix. Now, next thing that I want to do is I want to make predictions on a new set of data. So that's another thing that a lot of people ask is why don't we do some predictions? So I'm going to say, okay, I'm going to create a new data set here. pd.data frame, age, sex, CP. So I'm creating all these random values, and then based on these values, I'm going to go ahead. So this actually creates a new data sample, and then here I'm going to scale the new data that I've created. So I'm going to say new data scaled equal to scalar dot transform new data. This applies the previously fitted scalar to the new data. Next prediction is equal to based on the best model predict. I'm going to predict the outcome for the new data, and then I'm going to print out prediction for new data at risk disease if prediction equal to 0 equal to 1, else no heart disease. So I'm printing that out. Now if you want to change the data based on your details, you can change that based on your details in here and then see if there's a prediction for you for heart disease or not. But anyways, I am going to go run this and see how this works. Go ahead, open this. I'm in the right project, day 28, and here I'm going to say python day28.py, run it. There you go. It runs through the entire application, and we have the confusion matrix. If you see true positives and true, they're 100 and 105. That's pretty good. I'm going to close this, and if you see prediction for new data at risk of heart disease. So based on the values that I've provided, I think it says that I have chances of having heart disease. Now I can change the values, reduce the cholesterol, and bunch of different things here, and according to that, it might show me no heart disease prediction. But depending on what values you provide, it will give you a prediction right here. Again, from the top, if I look at it, it will show me that this is the sample data set which has all the values. I have these are the missing values. So it looks like there's no missing values. Everything is 0. That's pretty good. So we have a good data set. Again, depending on what data set you select, you might have missing values or not. So it's good to look at it. Logistic regression accuracy is 0.81, whereas random forest accuracy is 100%, which is pretty good. So I'm very sure it used random forest in this particular case. Now here is my best model matrix accuracy score of 1.2, which is random forest, and this is a classification report based on that, which is perfect, 100 over 100. So that's good. Next we have the confusion matrix, which we already saw in a graph format, which was nice. And then finally we have the prediction made here based on the data that we have provided. Now again, this is the project. If you were able to implement it, great. If you had any questions or had any issues in this, let me know in the messages and I'll get back to you.